Hello friend, we start the first chapter of digital technique, that is number system and codes. The first topic of this chapter is signal. First we see the definition of the signal. Signal is a physical quantity which have some information and which is the function of one or more independent variable. If we consider any physical quantity which contains some information and which can be represented by using one or more independent variable, then that type of physical quantity is called as signal. For example, temperature. If we draw a graph of the temperature, then the value of the temperature with respect to time, this graph shows the analog signal. This is the first type of the signal, and second one is digital signal, that we see later. First we discuss about the signal. See the definition. A physical quantity which contains some information and which is the function of one or more independent variable is called as signal. Simply, any signal have its own information and it can be represented by using one or more independent variable. Now we discussed about the type of signal. There are two types of signal. Analog signal and digital signal. The first signal is analog signal. A signal which have continuous and infinite number of values. Distinct value is called as analog signal. For example, temperature, pressure, brightness, distance, current and sound. These are the example of the analog signal. Now we are interested in these 2 points. Analog signal have continuous values. Analog signals have continuous values and they have infinite number of different or distinct values. Remember these 2 points: continuous values and infinite number of different or distinct values. This point can be considered when we write the difference between the analog signal and digital signal. Okay, these are the example of the analog signal: temperature, brightness, pressure, voltage, distance, current or sound. Now we draw the analog signal. Suppose we consider temperature as an example of analog signal. Suppose we draw the various value of the temperature with respect to time. This axis shows the value of temperature and this axis shows the value of time. Then we draw the value of temperature with respect to time. Suppose at 6 am the value of temperature is suppose 27 degrees centigrade. At 9 am, suppose this is 9 am, 6 am, 9 am, the value of temperature rises and it becomes 30 degrees centigrade. At 12 pm, suppose the value will be 32 degrees centigrade. Then we take the various point of the temperature. If we draw the graph of these values, then this is nothing but the signal. This signal have specific values, continuous value and infinite number of values. So this is the example of the analog signal. Now the second type of the signal is digital signal. A digital signal have finite and distinct number of values. A digital signal is defined as the signal which has only a finite number of distinct value. Suppose analog signal have continuous value, then digital signal have discontinuous or discrete value. Analog signal have infinite number of value, then digital signal have finite number of value. If someone asks what is the difference between the analog signal and digital signal, then we use these 2 points. Analog signal have continuous value, digital signal have discrete value. Analog signal have infinite number of value and digital signal have finite number of values. Example of the digital signal are binary signal and octal signal. Binary, octal, decimal or hexadecimal signal. These are the example of the digital signal. If we consider binary signal, then the binary signal are represented by using only 2 values, that is 0 and 1. 0 can be considered as the logic low level and 1 considered as the logic high level. Low level and this one is high level. This is the digital signal. Digital signal. Definition of digital signal is a digital signal is defined as the signal which has only a finite number of distinct value, and these are the example of the digital signal, that is binary signal and octal signal. Now the next point of this chapter is system or circuit. First we see the definition of the system or circuit. Consider we have to design a system, then we take a number of components or number of devices, and that number of components are interconnected to each other or number of devices are interconnected to each other to perform a particular task, to achieve a particular goal. Then system is formed. See the definition of the system or circuit. A system or circuit is defined as the physical device or group of devices or algorithm which can perform a required operation on the signal applied at its input. If we consider number of devices and that devices are interconnected to each other and we apply a particular signal at its input, then that system process on that applied input and produce a desired output. That is nothing but the system. This is the simple definition of the system or circuit. Now we discuss the type of system. There are 2 types of system or 2 types of circuit: analog system and digital system, or analog circuits and digital circuit. The first one is analog circuit. Before this topic we discuss the type of signal, analog signal and digital signal. The system is consider that 2 signal, analog signal and digital signal. Some system process on analog signal and some systems are processed on digital signal. With respect to the signal applied to the system and with respect to the response of the system for that particular signal, there are 2 types of system or 2 types of circuit. The first one is analog circuit. The circuit that process the analog signal are called as analog circuit. Some circuits process the analog signal. When we apply the analog signal to that system consider that applied signal as an input signal, process on that signal and produce the analog output. That circuits are called as analog circuit. The example of the circuits, analog circuits, are filter, amplifier and signal generator. Filters are the circuit which are used to filter the applied input. Low pass filter, high pass filter, band pass filter, band reject filter. Such filters are used to filter the applied input. Amplifier is a circuit which is used to amplify the signal. The process in which weak signals are converted into strong signal is called as amplification, and these amplifiers are capable to perform amplification. The device which is used to convert weak signal into strong signal are called as amplifier. And last one is signal generator. This circuit is used to generate the signal: sine wave, triangular wave, rectangular wave. Such type of signal can be generated by using signal generator, and these 3 are the example of the analog circuit. The second type of the circuit or system is digital circuit. In case of analog circuit, analog signals are processed. Now, the definition of digital circuit. The circuit that process the digital signal are called as a digital circuit. Analog circuit process analog signals and digital circuit process digital signals. The example of the digital circuits are adder, subtractor, registers, flip-flop, counters, microprocessor or calculator. Adder is a circuit which is used to perform the addition of the two binary bits or a group of bits. Subtractor is used to perform the subtraction of the applied bit or byte. Then register. Register are used to store the information. Flip-flop, counter, microprocessor, calculator, these are the example of the digital circuit. Now remember, first we see the definition of the signal. Then after the definition of that signal, we discuss types of signal, that is analog signal and digital signal. Then we discuss about the system or circuit. Then types of system or types of circuit, that is analog circuit and digital circuit. The next point of this chapter is number system. Remember the definition of the system. System is a collection of devices or algorithm or group of devices that are interconnected to each other to perform a particular task. Now we consider the number system. A system of numbers, a set of values which can be used to represent the quantity or a character. A character or a quantity can be represented by using a group of number. That group of number is called as number system. This is the definition of number system. A set of values used to represent a quantity is called as number system. Now we see the various important point of the number system. The first point is radix or base of the number system. Radix point or base of the number system. So this is the definition of the radix or base of the number system. The numbers or the values that can be used to represent the quantity. The values or the number which can be used to represent the quantity is called as base of the system, and the base of the system is also called as a radix of the number system. The second one is the largest value. If we consider a set of number, then it have a largest value, that may be 1, that may be 7, that may be 9, or that may be 15, that is equivalent to f. But every number system have a largest value, and that largest value is always less than the base of the number system. 1 less than base of the number system. Suppose the base of the number system is 2, then the largest value is always 1. If the base of the number system is 10, then the largest value is always 9. Last one is weight. Each place or the position represent the different multiple of the base or the radix of the number system. These multiples are called as weighted values. Now, the weight can be considered by taking this example. Suppose the decimal number is 239.75. 239.75. Now, what is the weight? Suppose this 2 is at 100 place, 1, 10 and 100. Then it can be represented like this: 2 into 10 raised to power 2. This is 10th place. Then 3 into 10 raised to power 1, 9. 9 into 10 raised to power 0. 7 into 10 raised to power minus 1, and 5 becomes 5 into 10 raised to power minus 2. This is the weight of that number. 1 place, 10 place, 100. Okay, this is the weight of the number system. The next point is conversion of the number system. Conversion of the number system. If any number if any number is given, then we have to convert that number into another number system. So what are the types of the number system in which we have to convert one number into another number? Then there are 4 number system: binary number system, octal number system, decimal number system, and hexadecimal number system. How we convert the number, or how many possibilities are there to convert the number? Suppose the binary number is given. Binary number is given. Then first, this number can be converted into decimal number, or binary number is converted into octal number, or binary number is converted into hexadecimal number. Means there are 3 conversions related to the binary number: binary number to decimal number conversion, binary number to octal number conversion, and binary number to hexadecimal number conversion. The second one is decimal number. Suppose the given number is decimal. First, it is possible to convert this number into binary, decimal number to binary number conversion. Second, decimal number to octal number conversion. And third, decimal to hexadecimal number conversion. Again, there are 3 possibilities of the conversion: decimal number to binary conversion, decimal number to octal number conversion, decimal number to hexadecimal conversion. Suppose the number is octal number, the given number is octal number. Then first, it is possible to convert the given octal number into binary number. Second, the octal number is converted into decimal number, or octal number is converted into hexadecimal number. The last one is hexadecimal number. Suppose the given number is hexadecimal number. The first possibility of conversion is hexadecimal number is converted into binary number. Hexadecimal number is converted into octal number. And hexadecimal number is converted into decimal number. These are the 12 possibilities of the conversion of the number system, and there are various methods to convert the given number into another number system that we can see in another lecture. Thank you.